video, I'm going to be doing some initial value problems, but before we actually get into the problems, it's important that we go over a differential equation. So a differential equation is the following: dy dx equals a certain function f of x. And I like to think of it as like, normally we like to take the derivative of a function to find what f prime x is, and this is the exact opposite of that. So in this case, we want to find the function that gives us the derivative of the following. So normally we're given the derivative, and we need to find the original function. So normally how you would solve these differential equations is you would integrate both sides of the equation. Just like how if you want to add a number to an equation, you have to add it to both sides. You can integrate both sides with respect to dx, and you can find the original function. For example, if I were to solve this, I would do the integral of dy dx in respect to dx equals the integral of f of x, which is equal to dx, and this would give us the solution y equals big F of x plus c. And the c is important because remember, when we take the derivative of a constant, it was 0. So if we take the derivative of this, we'll definitely get this, but this c can be anything. So whenever we do a differential equation, after we integrate both sides, you always have to add plus c on the right hand side. So again, differential equation is the exact opposite of taking the derivative, and normally we're given the derivative and we need to find the original function. So initial value problems are all about finding that plus c after we get the general solution of the differential equation. So again, what we need to do is we need to find an equation that satisfies both of these conditions. So the first condition is that dy dx equals 10 minus x, and the second one is that y of 0 equals 1. So again, if you remember, to solve this differential equation, we need to integrate both sides. So let's do that. So we're taking the integral of dy dx in respect to dx, and I'm taking the integral of 10 minus x in respect to dx. The integral of dy dx is just y, and the integral of 10 minus x in respect to dx is 10x minus x squared over 2. And remember, we cannot forget that plus c involved, so we have to include that as well. And this is our general solution. However, what we need to find is we need to find the specific solution that satisfies both of these conditions. And we figured out we did this condition right here, but we need to satisfy that condition, and that says y of 0 equals 1. So we need to find what that plus c is. They give us that when x is 0, y equals 1. So if you plug in those values here, we get 1 equals 0, right? Minus 0 over 2 plus c. And notice that c equals 1. So now we can find the particular solution that satisfies both these conditions. Given that c equals 1, we can write that y equals 10x minus x squared over 2 plus 1. So basically, the derivative of this will give us this. And if we plug in 0, we will get y equals 1. So the second problem is dy dx equals 9x squared minus 4x plus 5, and we need to find the particular solution such that when x equals negative 1, y equals 0. So again, the first thing we need to do is take the integral of both sides of this equation. So we have the integral of dy dx in respect to dx, and that equals the integral of 9x squared minus 4x plus 5. Again, respect to dx, and this equals the integral of dy dx is y, and the integral of this is 3x cubed minus 2x squared plus 5x, and remember, we cannot forget that plus c. So now, this is not our answer because we need to find a solution that at x equals negative 1, y equals 0, so we need to find the particular solution. That means we need to find what c equals. If we plug in x equals negative 1 and y equals 0, we get 0 equals 3 times negative 1 to the third minus 2 times negative 1 squared minus 5 plus c. 0 equals 3. Negative 1 cubed is negative 1, so we get negative 3 minus 2 times negative 1 squared is 1, so minus 2 minus 5 plus c. So 0 equals minus 3 minus 2 is minus 5, minus 5 minus 5 is minus 10, so minus 10 plus c. So we get c equals 10. So now we can write our particular solution, which is y equals 3x squared minus 2x squared plus 5x plus 10. So this equation satisfies both the first condition and the second condition. So the third problem is just like the last two, and it's dy dx equals cosine x plus sine x. given that y of pi equals 1. And again, we need to find the particular solution that satisfies both of these conditions. So I'm going to begin by integrating both sides of the differential equation like usual. So the integral of dy dx in respect to dx equals the integral of cosine x plus sine x, all respect to dx. This side equals y. And the integral of cosine x plus sine x, well, the integral of cosine x is sine x. And the integral of sine x, if you remember, what the derivative of what gives you sine x, so that would be negative cosine x, so minus cosine x. And remember, we cannot forget that plus c. So we have to have the plus c, and we need to now satisfy this condition, which says that when x equals pi, y equals 1. So 1 equals sine of pi minus cosine of pi plus c. 1 equals sine of pi is 0. The cosine of pi is negative 1, but since we have a negative in front, that becomes a plus 1. So plus 1 plus c. So now we get 1 equals 1 plus c, and c equals 0. So in this case, c equals 0, so this particular solution is just y equals sine x minus cosine x. So the fourth problem is a little bit more trickier than the other ones, and notice how instead of having a dy dx, we have the second derivative, and that is equal to 2 minus 6x, and we have to satisfy now two conditions, because we're going to get 2 plus c's, right, after the first integral and after the second integral, because we have to integrate this twice. So the first condition is y prime of 0 equals 4, and the second one is y of 0 equals 1. So again, like any of the other problems, we just need to take the integral of both sides. So the integral of d squared y dx squared in respect to dx equals the integral of 2 minus 6x in respect to dx. Remember, the integral of the second derivative will give us the first derivative, so dy dx equals, now the integral of 2 minus 6x is 2x minus 3x squared, and since we're taking the integral, remember we have to add a plus c here, so plus c. And now we can solve for this plus c by using this information that's given. We know that the y prime of 0, or dy dx of 0 equals 4. So when x equals 0, here dy dx equals 4. So 4 equals 2 times 0 minus 3 times 0 plus c. And now we know that c equals 4. So now we can rewrite this as 2x minus 3x squared plus 4. So again, remember, we're not done because we need to find what y equals given this condition. And right now, all we did was to take the integral of both sides and use this to find what c is. And we got dy dx equals 2x minus 3x squared plus 4. So now, again, we have to do the exact same thing. We have to integrate both sides to find what y equals. So the integral of dy dx equals the integral of 2x minus 3x squared plus 4 in respect to dx. The integral of now of the first derivative is just y. The integral of this is x squared minus x cubed plus 4x. And again, we cannot forget that plus c, so now we have a plus c over here. And now we can use this condition to solve for the plus c, and we know that when x equals 0, y equals 1. So 1 equals 0 minus 0 plus 0 plus c. So c equals 1, so we can rewrite this, find the particular solution, which is x squared minus x cubed plus 4x plus 1. So there you go. So what we did is that we came from the second derivative all the way to what y equals by using these two facts and integrating both sides. There you go. Thank you guys for watching, and please comment and subscribe below.